Now that you've gone through the basics of working with the most common style of many-to-many relationships using skip navigations, I do want you to have some awareness of the other ways to map a many-to-many with EF Core. One of these extends the skip navigations, but allows for some payload data. Another is to create and use an explicit class in between the two ends. And as I explained earlier, the unidirectional many-to-many. So this will just be a light intro to those. And for the unidirectional mapping, I'll just be pointing you to the documentation. The reason you would use either of these other two mappings is if you want to track more information in that join. For example, if you need to know when an artist was assigned to a cover or when the artist signed a contract for the cover. There may be a point where you have so much more data you want to collect about that assignment that you would just create a new class called assignment and connect it to the join entity. But if you just have a limited amount of data that makes sense to contain in that join, then these are the patterns you should consider. One of these mappings extends the skip navigations and let you have database or DB context-driven data included in the join. This additional data is referred to as a payload. What does that look like? First, you'll create a class to represent the join. And believe it or not, you won't be using this class in your code. Only EF Core will work with the class. This class needs to have the two IDs that reference the other entities. I might name this class Cover Assignment, and within it, I'll have an Artist ID and a Cover ID property. Now, the extra payload data is not something that you'll be able to code against outside of the DB context. So this is not a pattern if you want to have something like the date that the artist signed the contract. Someone would need to be able to specify that. But what if you want to have an audit trail for when that join was created in the database? That's a good use case for skip navigations with payload data. But in order to track it, we'll need an additional column that the simple skip navigation doesn't provide, which is why we need to have a class somewhere to put this property. And I've added the date created property to my cover assignment class. So how do we get that column populated? By specifying that the date created property maps to a column in the database that has a default value, for example, SQL Server's getDate function. Another key ingredient of this pattern is that it will not be recognized by convention. There's nothing in the artist or cover class that connects it to the cover assignment class. And the cover assignment class has no knowledge of the artist or cover class. For example, it doesn't have any navigation properties. So EF Core will just continue with the skip navigation that we were already using, unless you explicitly map this in the DB context on model creating. The mapping has gotten a lot simpler since it was first introduced in EF Core 6. And I'll leave this in the sample code for you to look at if you're interested. You can learn more about how to construct this mapping in the EF Core docs, which I'll link to the specific page in the resources. But I do want to highlight a few sections of the mapping. Here I'm referencing the relationship between artist and cover. This using entity method is how I'm telling the context to use the cover assignment class for the join instead of inferring that. And because I want the date created column to use SQL Server's current timestamp to provide its data, I'm using the hasDefaultValueSQL method on the date created property of our new class. And because I want it to use the existing artist cover table, I'm using the toTable mapping to ensure that. And finally, because I named the IDs in the new class Artist ID and Cover ID, but they need to map to the existing columns in the artist cover table, I have mappings here to indicate the column names for the mappings. While the DB context needs to be aware of the cover assignment class, you won't be working directly with it, so there's no need to add a DB set for cover assignment in pub context. I won't be demonstrating this in action, but if I were to create and run a migration, then the existing artist cover table would be modified with this new column. And then I could just continue interacting with artists and covers as I've done already. The artist and cover class are totally unaware of the cover assignment class, and you just don't work with that join class in your code. But the data model knows about it, and anytime I join an artist and a cover and save that, the database will be sure to put the date into the new column. Using an explicit join class in your many-to-many also existed through the entire history of Entity Framework and Entity Framework Core. Rather than ask EF Core to handle the join internally, you design your classes similar to how the database is structured, with an explicit class that connects the two. And like the database mapping, that class has a one-to-many relationship with each end, but those ends have no direct knowledge of each other. And with this join class, you can put as many additional properties as you want. You'll have access to this in code, so this is where you can have logic like the date that a contract was signed. Having an explicit join entity in the mix gives you very granular control over the relationship. However, it adds a layer, or two or three, of complexity to querying and building those relationships. If you want to query the relationship, you have to navigate through that join entity. There's a lot to learn about working with it, and I've actually covered both of these patterns in more depth in earlier courses, such as EF Core 2 mappings and EF Core 5 getting started. And I anticipate these being covered in other courses in the EF Core 6 path. But don't forget to go check the official docs, which also provide more in-depth detail. Many-to-many relationships are a very common pattern in our business domains, and I really appreciate that EF Core gives us a variety of ways to implement them depending on your needs. Skip navigations are the most natural way to express many-to-many in our classes, and while it might seem like magic when EF Core is able to interpret that into a relational database structure, it really isn't magic. There are just some very smart APIs supporting that capability. But the skip navigations are definitely the easiest to use for querying and adding data. Granted, due to the nature of many-to-many, it's a little more cumbersome to remove relationships, but now you know how to get that done. And if you need to track more information about a join, you saw that it's possible to add payload data while continuing to benefit from the ease of skip navigations. And when you need to pull out all the stops, you can always go back to describing the relationship as a pair of one-to-many relationships with a join entity in between. Although doing that will require more effort to code up your queries and connect objects on either end of the relationship. There's one more type of relationship we need to address, which is a one-to-one relationship, and the next module will focus on that. Here are a number of resources that I've mentioned in this module, including more information on mapping many-to-many relationships and links to some more information about creating indexes for foreign keys if you're interested in learning more about why migrations only created an index on one of the columns in our join table. I'm Julie Lerman, and thanks again for watching Entity Framework Core Fundamentals.